Here we're going to go over some examples from section 11.3. A bunch of basic area formulas. And number 3, looks like we have a square here. So we're going to do base times height, 1.6 times 1.6, base times height. And you might need a calculator for that. And we're going to get 2.56. Boom. Oh yeah, centimeters squared. So units would be like units squared because we're working with area here. Another guy. This guy is a parallelogram. So we gotta do base times height again. Base times height. You're always gonna find the height kind of next to a 90. So we know 16 is our height. The base is going to be those two guys combined. 18. So we can go 18 times 16, and we're going to get 18 times 16, 288. Now we have feet squared. Boom. Now, the triangles, it's going to be a similar situation. I'm going to go over a couple with you guys. This guy here, you've got your base 14, you've got your height 11, and you have this leftover 15 that we don't even care about, so cross that out. So we have a base times height, but with the triangle, then we're going to divide by 2 at the end. So we can go 40 times 11, divide by 2. Once you get these formulas set up, you just put them in your calculator and you're going to arrive at the right solution. 220 inches squared. Or another one like this guy here, number 2. We have our height next to a 90, so this is our height. Now you might think, oh, base, I'm going to add these two guys together. No. The triangle ends right here. So we're only going to use 22 as our base. Okay? Base times height. So 22 times 8, then divide by 2. I'm sorry, not 8, 16. 22 times 16 divided by 2. 176. So again, we're just using those formulas. Now it's time for the trapezoid formula. This is definitely a bit bigger of a formula. It's not like it's really more complicated, it just is a little longer. So you have base 1, base 2, and the height right here. Could you flip-flop B1 and B2? Yeah, you could. So now we're going to go base 1 plus base 2 times the height, divide by 2. And you're going to put all that in your calculator, and you're going to end up with 400. Boom. I would recommend doing these problems with your notes right next to you so you can kind of identify what formula you're going to use. Because if you mess up on the formula, you're going to get the wrong answer. Number 4. So we've got this trapezoid's kind of on its side. So base 1 is now over here, base 2, and again, we could flip-flop those, it doesn't really matter. But the height is the distance between your bases, okay? So height isn't necessarily height as in bottom to top. It's distance between your bases for a trapezoid. So, add the bases times the height, divide by 2. We should get a decimal here, that's my guess. $57.5. And last but not least, we're going to do a couple more, one kite and one rhombus. Remember, those guys have the same formula. So, this guy here, we got to find the kite And remember, diagonal area equals diagonal 1 times diagonal 2 divided by 2. Okay, that's it. So we need to find the diagonals. Well, how big is this diagonal? 20 plus 20, 40. How big is this diagonal? 56 plus 26, 82. And then divide by 2. Okay. So, zoom out here more so you can see better. So now, I'm going to pop that in my calculator. I'm getting 1,640. Boom, there you go. I should put my units, inches squared. And last but not least, this guy here, this is a rhombus. If you're like, there's no markings on it, first off, you're right, there are no markings on it. But the problems do tell us that we're working with rhombuses and kites. So diagonal 1 would be 7 plus 7, that's 14. Diagonal 2 would be 8, and this is going to have to be the same. 8. Because remember, with what's it called? With parallelograms, diagonals bisect each other. So if this is an 8, we know that's an 8. 8 plus 8 is 16. And then we're going to divide that by 2. Now we're going to have 14. Boom. 112. There we go. So, there's some examples for the area formulas. Please let me know if you have any questions. Thanks for watching.